All right, so we're going to review moles here. The two relationships that you need to know is that 1 mole is equal to 6.02 times 10 to the 23rd atoms, or molecules, and that 1 mole is equal to the molar mass of a material. How do we find the molar mass of a compound in order to understand this second relationship right here? Well, we're always going to be looking on the periodic table. So when we look at the periodic table, underneath the symbol is going to be what is also known as the molar mass. We learned last semester that it's the total of protons and neutrons and an average mass of the isotopes. Well, now we know that that molar mass is also equal to 1 mole of the material. Now, what about a compound? If we have a compound, like a material that's made up of more than one element, like let's say carbon monoxide, we're going to have to take those two elements and we're going to have to add the molar masses of each of the elements together. So to find the molar mass of carbon monoxide, we would have to take 12.011 and add 15.999 and add those together in order to get the molar mass of it. So the molar mass is about 28 grams in 1 mole. That's called the molar mass. So using those two relationships, we're going to do a couple of practice problems. Our first practice problem is going to focus on moles and molecules. So the thing that we want to make sure that we remember is that 1 mole is equal to 6.02 times 10 to the 23rd molecules, or it could also be atoms. So if we have 2.2 moles, and we want to find the number of molecules, we're going to use that relationship. So we always start with what we're given. 2.2 moles is what I identified I'm being given. Now, if I look at this relationship, 1 mole is equal to 6.02 times 10 to the 23rd atoms. So if I had 2.2 moles, I would simply be multiplying it by 6.02 times 10 to the 23rd molecules. Now, I've also taught you how to do this setting up a ratio, using this number right here as a ratio. So I've taught you to put 1 mole on the bottom so that our moles units cancels out. Well, any number over 1 is simply itself. So that tells me that I'm going to take my 2.2 moles and I'm going to multiply it by 6.02 times 10 to the 23rd. I've set it up that way so that you can see that my moles unit right here cancels out with the moles unit I started with, and that leaves me with my answer in molecules, which is what I wanted to find. So now, by setting up that ratio, I know that my answer is in molecules, and I know that I'm taking this number and I'm multiplying it by this number. If I want to go the opposite way, if I start with 3.76 times 10 to the 24th atoms, I have taught you to set this up as a ratio with the unit of atoms on the bottom so that my unit of atoms here cancels out with each other. That's the unit that I want to get rid of because that's what I'm beginning with. This right here is what I'm beginning with. What's the unit I want to get to? I want to get to moles. So that unit of moles is going to go on the top. Now, I'm going to look at this relationship right here of 1 mole equals 6.02 times 10 to the 23rd atoms, and I'm going to fill in the numbers next to their correct units. So according to this relationship right up here, I'm going to put the number 1 next to the word moles, because that's what it says right up here, 1 mole. And my number of atoms is going to be 6.02 times 10 to the 23rd atoms. If I look at this relationship right here, 1 over 6.02 times 10 to the 23rd, mathematically, what I'm doing is I'm taking my beginning number, 3.76, times 10 to the 24th atoms. My unit of atoms is canceling out, and I'm dividing it by 6.02 times 10 to the 23rd atoms. because 1 times this number goes on the top here, and then there's like an invisible 1 underneath here. So 1 times this number goes in the denominator. And so if I need to go from atoms to moles, I'm going to take the number of atoms I am beginning with, which is this number right here, the number of atoms I'm starting with, and I am going to divide it by 6.02 times 10 to the 23rd atoms. So we can see that we're setting up the ratio so that we can see that moles cancels, so that we're left with molecules, or we're setting it up with atoms on the bottom because atoms is what we're starting with, and that way our atoms cancels out and we end up with moles as our answer when we take these two and divide them. What about the relationship between moles and grams? Well, the relationship here is that 1 mole is equal to the molar mass. And we have to look on the periodic table to find molar masses. So, again, first identify what you're given. I'm given 1.8 moles. So that's going to be what I start with, 1.8 moles. What's the unit that I want to get to? Well, the unit I want to get to, it's asking me for grams. So right away, I can see that I'm going in this problem from moles to grams. So that's how I know that I'm going to be using this relationship right here. So I don't want moles anymore, so I'm going to put the word mole on the bottom. I want to get to grams, so I'm going to put grams on the top. So I need to find out how many grams are in 1 mole of water. Well, water is a compound, so I've got to look at hydrogen, and it has a mass of 1.01, so I'm going to multiply that by 2, because I've got 2 of them. So my hydrogen is contributing a mass of 2.02. Oxygen, I'm going to go ahead and round the mass to 16. I just have 1 of them. So the molar mass of water is 18.02. That's how many grams are in 1 mole of the material. So this relationship right here, I'm going to put into this factor right here. So 1 goes at the bottom by mole, and 18.02 goes by the grams. So we can see that our moles cancels out, and basically what we're doing is we're taking 1.8 moles and we're multiplying it by the molar mass, because any number over 1 is simply itself. That's going to tell us how many grams, which is what we want to get to. Let's try another problem. What if I am given 122 grams of HNO3 and I want to know how many moles there are? Let's start with what we're given. I highlighted in yellow that we were given 122 grams of HNO3. I want to get to moles, so I'm going to go ahead and set up my relationship. I don't want grams anymore, so grams is what I started with. So grams is going to go on the bottom, so it cancels out. I want to get to moles, so moles is going to go on the top in my relationship. Well, I'm still going to be using this relationship up here. 1 mole is equal to the molar mass of the material. So I'm going to fill in those numbers. 1 goes next to the word mole, and the molar mass of HNO3 needs to be calculated. So hydrogen has a mass of 1.01, nitrogen has a mass of about 14, and oxygen has a mass of about 16, but I have 3 of them. So I have to add that all together in order to find the total molar mass of HNO3. So I've got to find how much does 1 mole of this material weigh. So 1 mole of HNO3 weighs about 63-ish grams. So I'm going to put that next to my G, 63 grams. So here my grams cancels out, and I can see that if I start with a unit of grams and I want to get to moles, then I'm going to take the grams that I've been given and I'm going to divide it by that molar mass. So mathematically what we're looking at here is we're taking 122 grams and we're dividing it by the 63 grams. We've multiplied it by 1 mole, so our grams unit cancels out, and we're left with an answer of moles when we take the number 122 and divide it by that molar mass of 63. What about a two-step problem? We know these two relationships at the top. 1 mole is 6.02 times 10 to the 23rd atoms or molecules. We also know that 1 mole is equal to the molar mass of a material. If we look at this first problem, we're given a number of atoms, and it wants us to get to grams. But if I look up here at my two relationships, neither of these say grams are equal to atoms. We don't have anything that has these two equal to each other. So we're going to have to do 2 steps. I'm still going to start with what I'm given. I highlighted in green 3.8 times 10 to the 24th atoms. Again, I don't want atoms anymore, so atoms goes on the bottom. I'm going to have to get to moles first because these things both have moles in common so that I can get directly to my answer of grams. So I'm going to put atoms on the bottom and I'm going to get to moles first. 1 mole is equal to 6.02 times 10 to the 23rd atoms. I'm going to solve for this first. My answer is going to be in moles. My next step then is going to not be in moles anymore. I don't want moles anymore. I actually want to get to grams. So I'm going to use that relationship of 1 mole is equal to the molar mass of water. Well, 1 mole of water has a mass of 18.02 grams. We figured that out earlier. So my molar mass goes on the top. So whatever answer I get from the first step, where I'm taking 3.8 times 10 to the 24th, and I'm dividing it by 6.02 times 10 to the 23rd, that's going to give me my answer in moles. Then I'm going to take this answer in moles, and I'm going to take it and I'm going to multiply it by 18.02. That right there is going to have me cancel atoms to get to moles, and then cancel moles to get to grams. And my answer will finally be in grams then. Now I can actually shorten those 2 steps because there is a relationship between molecules and grams. Since 1 mole equals 6.02 times 10 to the 23rd, and 1 mole equals the molar mass of a material, we can actually look at the relationship that 6.02 times 10 to the 23rd atoms is also equal to the molar mass of the material in grams. So that last problem we can actually do in just 1 step if we realize that we can put these 2 relationships together. So in the previous problem, I gave you a certain number of atoms. I'm just going to throw a new number out there. Let's say I give you 5.2 times 10 to the 23rd atoms. And I tell you, I want to know how many grams that is. Well, let's look at this relationship right here. We're still talking about atoms of water, just like in the previous problem. Well, let's use the relationship that we just made in order to solve this problem. Well, I don't want atoms anymore, so atoms is going to go on the bottom because that's what I'm starting with. I want to get to grams, so grams is going to go on the top. Well, this relationship right here says that there are 6.02 times 10 to the 23rd atoms. So I'm going to go 6.02 times 10 to the 23rd right next to the word atoms. It also says that that many atoms equals the molar mass of the material. So I'm going to go ahead and put my molar mass of water because we're talking about water. So the molar mass of water is 18.02 grams. So what happens here is atoms cancels out and we're left with an answer of grams. Mathematically, what are we doing here? Well, we're taking our atoms and we're going to multiply it by 18.02 and then we're going to take that answer and we're going to divide it by 6.02 times 10 to the 23rd. So in your calculator, you can literally put into your calculator 5.2 times 10 to the 23rd, parentheses, 18.02 divided by, parentheses, 6.02 e to the 23rd power, end of parentheses, end of parentheses. What we're doing is we're taking 5.2 times 10 to the 23rd, we're going to multiply it by 18.02, and then you're going to take that answer, and whatever this answer is here, You're going to divide it by 6.02 times 10 to the 23rd power.